SQL. So before we get started and to get a little bit warmed up, here is a big and important question. How do you feel about joins? So what's your feel? What's your favorite join? What's your general sense of joins? How do you like joins? Full outer join. Never lose any data. I like that one. Confused. It's all right. Full outer join, inner join. Joins have been pretty good so far. That's a good description of how we tend to feel about joins at the beginning. It's 50-50. Not that type of join. No. Confused, right join. One time is okay. All right. So today we're going to be working quite a bit more with joins because it's going to be important and it's going to help us understand also how to deal with data a lot better. So apart from that, we're also going to be working with aggregate functions. And we already did a little bit of this. And importantly, they are very similar to the aggregate functions we use in Excel. The only difference is how we use them or what are our options to using them in SQL. And again, we're going to use count, sum, average, max, etc. I'm going to leave this here for a second to talk about our ERD, and let's go into the case and start working on SQL today. So today we're going to learn how to use both aggregate functions and subqueries to summarize data within a database. So that way we can take a lot of data, a lot of tables, and we can figure out how to find the specific information we actually need to find or we actually want. This is also going to help us a lot to understand how databases are structured, because most of the time things are set up in multiple tables. It's not just one table. And there's a reason for it. We don't want to duplicate information. So probably the most common example is you have on an online retail store, there's one thing is the clients table, which has all the information on the clients, including a unique ID for each of them. And then you have one table for all of their transactions. So every time they buy something, we actually just put their customer ID, the client ID. We don't use all of the other information because if not, we would be just duplicating their name, their last name, their address over and over again, which makes no sense. So we need to save up space. And for that reason, we use relational databases. And that means that we have all of these tables, all of them organized in different places. So today we're going to be working with these three tables. And by the way, I'm going to actually put them on the screen as much as I can whenever we're doing exercises so that you know exactly how they are connected. So they're called relational because they relate to one another. And generally, they relate using some kind of an ID. So what's happening here is, for example, we have an agent. So this is our list of agents. And we'll talk about the case in a bit. So imagine that this is a call center. We have agents. And every agent, we have their name and maybe some other information. But for now, the name is more than enough. And each of them has an agent ID. Then we have customers. So every customer has a customer ID, and we have a ton of information on them. So each of them, remember, is a column inside a table. And finally, the way that these two interact with each other is through the call system. So a customer calls in, an agent picks up the call, and that every single call gets registered. So there's a call ID, and as you can see, there's the agent ID over here, which is this one. So it follows this path. In other words, this agent table and this call table are connected through the agent ID. And then we have a customer ID, which tells us who the customer was. And this is this connection over here. So again, if one customer calls 20 times, there's going to be 20 calls in the call table. But we're not going to copy all of this information 20 times. It's only going to be there once. And the only thing we copy is this customer ID. So there's going to be 20 calls for one customer ID, but the information for the customer, we only have it once. Same thing with the agent. It doesn't matter how many calls an agent takes. All that matters is that the only thing we copy from this table is the ID, not anything else about the agent. So that means that when we actually want to do queries, and we need to get some kind of information that interacts with every single one of these tables. We need to join them together one way or another. So what is our case today specifically? So your work for the HR department in a large financial services corporation, and that sells a lot of financial products. So imagine anything from loans, credit cards, think about any financial product. At this point in time, it's not really that relevant, but that's what they sell. So we have all these agents, and the way they do it is they have a call center. So the sales agents make calls. So the agents call, either cold calling or warm calling, it doesn't matter. And they call prospective customers, they talk to them, and they try to get them to buy something. And what they want us to do is to figure out how they're performing, how they're doing. Are they doing a good job? Are they doing a bad job? Who are our best performers, etc. So the problem, or what we want to actually figure out, is which of our sales agents are the most and the least productive. In other words, the ones that are doing a best job or are being the better salespeople, and the ones who are doing the worst job in sales. So in the context, as we talked, we have an SQL-like database. In this case, we have 3 tables: the agent table, the call table, and the customer table, which again, we see it in, this is the schema. This is how the tables are connected together. All right, so we're going to work a little bit on practicing some fundamentals, especially doing some joins. And we're going to do a lot of select statements that are going to help us to find interesting things about customers. And we're going to use a lot of aggregations to compute and figure out who are the most and the least productive agents in our company. So let's get started. First of all, as usual, we want to hit this big blue button. So remember, if you're working on a localized system, there's several copies of the database already on the chat. And feel free to just load it there. If not, click on this blue button just to get the SQLite server started. Once it's open, we're going to go here where it says Open Database and click on that one. We're going to pick the call center database 2. And we're going to hit the Open button. All right. Hit Open. Once you're here, you're going to go into Execute SQL, because that's where we want to go. So just click on that tab, and we're ready to start doing SQL code. All right. Wow, that's a great, incredible, Kishan. That's a great question. How and when do we create a schema? The schema you create when you're designing the database. So you design the database, you create the schema, and then you code the schema onto SQL to open up all the tables. All right. So we are not actually going to do that, because that is a completely different course and a completely different thing that has nothing to do with what we do most of the time. Most of the time, data analysts are not in charge of building SQL databases. All we do is actually query the data and use it to do or different kinds of analysis, like we're going to do today. So once more, after you start the SQLite browser, you're going to go over here to Open Database, just very quickly. Then you're going to click on Call Center Database 2, and finally Open. All right, so we're going to open it up. That's going to get open, and finally, you're going to click once more on Execute this tab, Execute SQL. And there you're going to be able to do our SQL code. Table and schema are similar. So schema, think about this. All of this is the schema. So all of this is the schema for our database. This is one table. So that's what's different. So a schema is all of the tables inside a database and how they're connected between each other. All right. So, yep, we do that. So we took a look at our database already. So again, we have our agent table that has, let's look at it a little bit bigger. So our agent table, all it has is their agent ID and their name, because it could have more information, but at least in this time it doesn't, because we're not going to need it. Then we have the call information. It has the call ID, the agent ID that tells us who the agent was, the customer ID that tells us who the customer was, whether the call was picked up or not. So 1 for yes, 0 for no. the duration of the call, and how many products, and whether there was a product sold or not. So 1 for yes, 0 for no. Then we have the customer table that has a customer ID, the name of the customer, the occupation of the customer, their email, company, phone number, and age. So there's quite a bit of information, and we're actually going to go through it. Yes, so Magda, I think there's already a couple of copies of the database on the chat, but if somebody, one of the TAs could actually load it up again, that'd be wonderful. All right. So as I said, it's very important to know how the tables interact with each other. And the most important thing is that agent ID, and through the agent ID, these two tables are connected, agent and call, and through customer ID, the call and the customer tables are also joined. Thank you, Sophia. Thank you, Marta. Thank you. That's great. So there's a copy again of the database just in case. All right. So let's talk about doing some of our joins, which we've been talking about a bit, and they become very important. And it's even easier if we actually understand how everything is related between each other. So let's actually start with taking a look at our agent table. So we're going to select all from agent. And as we can see, so again, we click over here to run it. So we have exactly, let's see if I'm looking at them. Yep, that's all of them. Right? Yeah, we have 11, exactly 11 agents. So it starts with ID 0 all the way to ID 10, but we have 11 agents and we have their full names. All right. So that's good to know. We all already have it. So again, 11 agents, their IDs run from 0 to 10. And we can actually take a look at our call table. So let's actually do that. Select all, because we're going to see something interesting here from call. So this is our call table. This is the table that registers every single call that our agents make. And we're going to order by agent ID. So we're ordering by these numbers over here, because remember, the call table also has an agent ID column, which just is recording these agents over here. I'm going to run this one. And there's a few things that there's something that I want you to point out that's very interesting. This is strange. What is strange about this first row? Exactly, there's a -1. Did you see, was there a -1 on our agent table? No, there wasn't. So this is weird, and this is something we need to take into account at one point. So in most cases, whenever you find a negative number that you're not expecting, especially if it's a -1, it can actually say that there was some kind of an issue. And we will figure out and do some follow-up to figure out this out during today's lesson, but because it's important. Is it the robot? Maybe. Well, maybe. But most of the time, if we find this, it's some kind of anomaly. And we have to think about that. Okay, what's happening here? So let's start first by thinking about the different kinds of joins that we can do. So there's two very important concepts that we definitely need. The difference between an inner join and an outer join. So let's think about agent .agent ID. In other words, these are the agent ID column in our agents table, and the agent ID column on our. So we have something different, as you can see. Actually, let's actually do this just so we can see it more clearly. Select distinct agent ID from call. So again, I'm just asking for the distinct agent IDs. And again, we have 12 instead of 11, which is what we had in the other table. We have this extra -1. So in our agent table, this is our set. Imagine that these are the agents that exist in that table. They go from 0 all the way to 10. But in our call table, we have 11 agents, starting with -1 and ending up in 10. So again, when we talk about sets, we talk about Venn diagrams. Why Venn diagrams? Because we have set A and set B. This is our agents table. This is our call table. All right. So let's actually think about the difference between our two kinds of joins. So A is the difference, is everything that's in table, the agent table, that is not in the call table. Okay, because remember, these are our sets right now. A is all of the agent IDs from our agent table, and B is all of our agent IDs from the call table. All right. So here's an interesting question. If this is our agent table and this is our call table, let's actually call this one. This is our agent. It's so hard to write with the mouse. And this is the call table. All right. So here's a question. What is this part? What exists in set A that does not exist in set B? So what is A in this case? So remember, A is agent, B is call. No, we're just talking about the names. Sorry, not the names, just the numbers. Remember, let's actually take a look at this again. 1 second. Remember, we have these two. A is the numbers, the IDs for the agents, and B is the number of the IDs for the agents on the call table. That's the difference. So what would A be? So yeah, A minus B. So interestingly, A would be empty. So this would be what's called an empty set, which you just looks like this, meaning that there's nothing in it. What would be B? So everything that's in B that is not also in A. Exactly. In this one, I'm just going to do, exactly. Here we have -1. This would be the green part. What about this part over here? The orange part. What do we have here? Yeah, great. So wonderful. This is 0, and I'm just going to do dots all the way to 10, because these are the ones that are in both data sets at the same time. All right. So that's the basic concept of what we're going to do with joins. This is how we think about sets. So let's actually start thinking about what we are going to do in particular. So it turns out that we have different kinds of joins. All right. So an inner join means whenever we do when we just say join, SQL understands implicitly that we're doing the inner join. So inner join is this over here. Okay, let's actually do another example. Let's say that A has number 1, 2, 3, and 4, and B has the numbers 2, 4, 5, and 7. Okay, so the yellow area, in other words, what's in A that's not in B? Just look at these. So these are our sets: 1, 2, 4, 3, and 2, 4, 5, 7. So what would be in A that is not in B? What's our yellow area? Exactly. Our yellow area would be 1. Oops, would be 1 and 3. So this yellow area is 1 and 3. What about our green area? Yep, our green area would be 5 and 7. All right. What about the orange area, the one that's both, that has both of them? Two and 4, correct. So this is what we think of sets. So 2 and 4, that would be the inner join. Okay, it's what's in this table that's also in this table. So whenever we do just a regular join, or what's called an inner join, this is what we're doing. We're telling it, please give me all of the information that is in both of these tables at the same time. All right. So this is my inner join. So if it's in table 1 and it's also in table 2, that's what I'm going to get. So let me go back over here. That would be the inner join. Now, the outer join, so inner join, it's going to return all the records that are matching values in both. So if it's in both tables, we get it. Now, the outer join, we have 3 kinds of outer joins. All right. We have the right join, the left join, and the full outer join. All right. So let's actually, so let's go back 1, 2, 3, and 4. We have 3, for, just to make it simpler, 5 and 6. That's what we have here. So the green area would be just 5 and 6. The yellow area would be 1 and 2. And the inner area would be 3 and 4. Okay, because it belongs to both. So if I do a full inner join, not a full inner join, an inner join or a regular join, I get 3 and 4. Now, a left join is going to take my left table, which is A. It's going to take everything from that table. And from this table, it's going to take only what's in both tables. Okay? So what's going to happen is it's going to take 1 and 2, 3 and 4 from this table. And any information that they have in these 3 and 4 is also going to be taken. Okay, so that would be a left join. So if you think about if these, for example, if these if these are our agent numbers and these are our calls, it's going to bring all of the names of the agents here and every single type of information from these calls over here. But it's going to ignore these ones. So these ones are not going to exist. All right. Now, the next part. If all of these is going to happen, if I do a left, this is a left outer join. Okay, left outer join. What's going to happen if I do a right outer join? What information do I get? Exactly. So I get 3, 4, 5, and 6 from here. So all of these, everything on B and table B, and these two over here. So any information that A has on 3 and 4. All right. So that would be a right join. 3, 4, 5, and 6. So here's an interesting question. Why is it that a lot of people, and why is it that a right join gets a bad reputation? And most people don't do right joins. And the quick reason is because if you wanted to get all of the information from B with whatever information A has that also is required on B, you just do B left join A instead of A right join B. That's it. Because you can always just switch the tables around. Now, finally, what would an outer join give you? A full outer join. So that's the best one. So a full outer join is going to give you. So if, let's remember, this one has information on 1, 2, 3, and 4. And let's say that this one has A, and A. And then this one has 3, 4, 5, and 6. And then inside the information says B, 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 and B. So what's going to happen at the end is I'm going to have one table that has 1A, no B, 2A, but no B, 3A and a B, 4A and a B, then 5B and 6B. So it's going to take all of the information from both tables, but it's only going to join. So for example, since there's a 3 here and there's a 3 here, those get joined into A and B. And that's it. That's the whole idea with full outer joins, inner joins, etc. All right. Could I start the explanation from the top? Wow. Actually, because we have a lot to go through today, I'll actually leave it so that you can see it again. And if we have time before the break, I'll go through it again. And I'll give you another explanation on it. If not, I'll record it and just upload it for you because we really have a lot to get through today. All right. So let's do a little bit of an example. Let's actually join and see the join table between customer and call for only common values. In other words, let's do an inner join. So I'm going to select, in this case, I want everything from customer and I want to join. So remember, I don't actually have to say inner join, but you can if you want. You just do join, call, and we're going to join it on customers from the customer table, the customer ID, and equals from the call table, also the customer ID. Okay, and this is what we get. So we get a whole list of every single customer ID, and every call that they've had. So as you can see, we have customer 0, customer 0. These are the same people, and we have several calls for them because we're getting everything that for every client that has had a call. So in this case, yes, so we're going to see the difference in just a second. So yes, a customer is our left table in this case. The first table would also be considered the left table, always. Then, so that's our first join. Now, what happens if instead of a regular join, I do a full join, which would be a full outer join? In other words, I'm getting all of the information from both tables. And this is what happens. So we have, let's see over here. So we have all of the calls from every single client. And then all the way at the end, we have these null values. So we have no information on the clients or no client information, but we do have agent and call information. Okay, so there were a few calls where the client was not registered, but we still get them here. If I remove the full join, we don't get that information. Let me actually do this again. So if I go all the way down here, as you can see, it goes all the way to client 999 and no null values. If I add the full join, because now I'm getting all of the information from the call table, and it does have some calls that have no client information. And that's the whole point and the whole thing. Don't worry, again, if you're confused before the break, I'm going to do a little bit or just after we come back from the break, I'll give you another example of how to look at this. See if that helps clear it up. Let's actually do an exercise to get warmed up, just in case. So do a join table between agent and call. So there's two tables, remember? We have the agent table and the call table. And I want you to do a join between these two tables. Only the common values. So only the stuff that's in agent that's also in call. In other words, think about what kind of join you need to do. And I'll give you a couple of minutes for this one. Let's do the timer here. So again, I want a join table between agent and call. So the question that we're working on is this one. I want you to write the code to join agent and call on their common values. All right, we're getting some answers. And we're almost done on this one. All right, so yeah, great work everyone so far. So if we want to join the agent and the call table, we select all from, I'm gonna do agent in this case. It doesn't actually matter the order particularly, but I'm gonna take agent first and then join call. And I'm gonna do on agent dot agent ID equals call dot agent ID. And that should be it. So again, all that, well, yeah, you can order it. I'm not going to, yeah, let's order it. Why not? That's actually a good idea. Order by agent. Oops. Agent.agent ID. And this is not going to work if I don't fix it. There you go. So we have agent. So here's the thing, and this is important. So this is the list that you're going to get. So if this is an inner join. Remember, when we just use join, what's going to happen? It's an inner join. It's the values that are in both tables that are going to be shown. Now, here's a question. What happens if I switch these around? If I do call an agent in this case? So what happens if I do the call table first and the agent table later? When I run it, so the difference, if you can see it, is going to be what gets shown first. So if I do call first, then the call information is going to get shown first. But the table, except for the order of the columns, is going to be the same. If I do agent first, then the agent information is going to be shown first. So the order does matter depending on what information we're going to be looking at. Yeah, you should get that. So you should get the same amount of rows. So let's actually check that out. So here we have 9,939 rows. If I switch it around, call versus agent, these are all great questions, by the way. If I switch it around, go all the way down, boom, we have 9,939 rows. So it doesn't matter which way because it's joining, it's giving me the information that's available at both tables. All right. So second exercise for the day. Modify this query over here. I'm actually going to change it back to agent and call in that order. So modify this one so that it shows every single row in both tables, so that we get all of the information. Or in this case, but no, actually don't do it with a full join. It says do it like here. So get me everything from the call table and then join the agent table. So everything from the call table and then join the agent table. All right. So again, everything from the call table and join that to the agent table. All right. So let's talk about this one a little bit. So there's two ways of doing this one. I can definitely think about doing a full join if I want to get all of the information from both tables. And again, if I do a full join, I get an extra layer. In this case, I'm going to get one extra row, which is the one for agent -1 that exists on the call table. Now, nonetheless, if there was some information in the agent table that I did not want, then the full join will not work. Now, it's not the case here, but we can do this a little bit differently. We could actually get all everything from call, and then we can do a left join. Remember, left join means I'm taking everything from call and then joining agent. Everything else stays the same. And I still get my -1 row, the one that has no information on the agent. Why? Because the first part is getting all of the information from my left table, which in this case is the call table. We could actually do it the other way around with a right join, but I don't want to make it complicated. All right. So let's actually start looking at some other interesting stuff that we can do, because we need to start thinking about how to evaluate our agent's performance. So we need some aggregate functions. Now, what do they do? The important thing with aggregate functions is that they return one value. All right. So for example, count, it's going to count all of the rows, a specific, all of the rows based on a particular column, okay, or table. And again, it's just one number. It's just counting them, just like in Excel. Sum, it's going to sum the values of that particular column. Average is going to give you the average of the values of that particular column. Minimum gives you the minimum value, and maximum gives you the maximum value. So let's actually do a couple of them and see what happens. So let's do select count. So we're going to do count, and I'm going to use all. So remember, when you use all, you're saying, I want to count all of the rows, not just one of them, but all of the rows. All right. And this is going to be called as total calls. So this one's actually that's better. Total calls. So in other words, this is what I'm now, when it pops up as a column, this is the name I want to give it. Because again, I'm going to get one value and just one value. Let's do the sum of product sold. So remember, product sold is a Boolean, meaning that it's a value either 1 or 0. We have it over here in the call table. So if it's a 1, meaning it means that there was a sale. If there's a 0, it means that there wasn't a sale. So as I sum them up, I'm going to get the number of sales. So this one's going to be as total sales. And I'm just going to do it from the call table, because that's all I need, from call. So this is what's going to happen. So when I run this, so count is going to count all of the rows, because I'm asking it to count all of them. All of the rows in my call table, it's 9,940, which we've seen before. And this is going to sum all of the 1 and 0s in the product sold column. And in this case, there's 2,089. So this is an interesting way, and we're just already figuring out how to know how many sales there were, how many total calls there were, etc. All right. So questions about these two? Good. All right. Do you have to use commas where? Like this one over here? Yes. The answer is yes. So remember, anything that you ask for in the select statement, every piece of it has to be separated by a comma. The only one that doesn't get a comma is the last one. If you put a comma here, you're going to get an error because it's expecting something else. All right. So, oops. So it's very important, but every single item that you put in your select statement has to be separated by a comma. All right. So how do we figure out how our agents are doing? So yeah, this is great. I have the total calls, I have the total sales, but how do I figure out how my agents are actually doing? Oh, that's a great question, by the way. So anything that follows the as statement is an alias. That's what AS means. It's alias. I'm just aliasing this not column. Now, you don't actually have to use it. But the issue is, if I don't use it, this is what happens. That's why it's good practice. See, this is just saying this is count. So it's just giving this, giving the column this name, exactly what I did. And sum, again, sum product sold. That's exactly what it's going to do. Yeah, the syntax error is because you forgot the comma after the first item in the select statement. So very important. Let's do this again. If you're going to put more than one thing on your select statement, you have to separate them by commas. Kimi, in the previous example, why did I do a left join? Because in this case, remember that I wanted everything from the call table and then anything from the agent table that connects to it. So the important table was the call table. If there was more stuff in the agent table that I didn't want, then a full outer join would have given me more information that I actually expected. So that's why we have different kinds of joins. All right. So we already know how to do this, and great. This information is wonderful. But what happens if I actually want to know the values by different agents? So the great thing is that we can actually do this using group by. So group by, if I group by anything, I can group by anything I want over here, like any column that we have available. Exactly. Group by agent ID. We would get the same information by divided into how many agents there are with their actual name. Well, depending on how I exactly do it. So let's do a quick exercise. So we want a query. So think about it. Think about the group by statement. Write a query that outputs the agent's name, the total calls that each of them made, and their total successful sales. So in other words, I want count and I want some product, but I want them grouped by agent. And remember, you're going to need a join. So this is what we want. Again, I want you to write a query that gives me the number of calls and the number of sales for each agent. All right. And let's. Oh, and if you need the schema, it's here. All right. So let's go over this one. So again, we want to write a query that's going to give me the agent's name, the total calls that they made, and their total successful sales. So how do we do this? Let's start from the beginning. So select the first thing that I want is the name. So agent, this is going to become important, agent dot name. So from the agent table, I want their name. Why am I doing this up here? Because I'm going to be adding more stuff. This is not just the only stuff that we have. So again, we're going to do also count all as total calls, and we're going to do some product sold. Let me just check. Yeah, product sold, and this is going to be total sales. Now, this is where it starts getting interesting. So we're going to get all the information from, I'm going to do an inner join from call join agent on call dot agent ID equals agent dot agent ID. So again, this is on call the agent ID from the call table equals the agent ID from the agent table. And here's the important thing: group by. I'm going to do agent dot name. So I want to group by the name of the agent, and yeah, why not order by? You know what? I'm just going to order by agent name as well. I mean, we could order by product sold, but in this case, it doesn't really matter. I just want to be able to see the differences between the agents. So by the way, these order by is just going to give me an order list alphabetically. So let's run this, and I get agent X. So again, what it does is that once I use this group by, these aggregate functions get divided into whatever's there. So in this case, why am I doing a full join instead of a left join? Because I only want information that it's in both tables. I really do only want the information that is available in both tables at the same time. So I want to leave out any weird mistakes. For now, that's important for now. So this is how we get this one done. So the one thing that we could do, and this is going to become important before we actually go on a break, the stage of select statement, so we don't have to do many. So yes, wow. Yes, there are abbreviations for tables, but they become a little bit more complex, and I don't want to confuse you today. We're going to cover them next week, not next week, next session. So, but yeah, there is a way, but let's not get into it today because it doesn't happen in the select statement. It happens in the from statement, which makes it a little bit more complex. But yeah, it happens. All right. So the one thing that we could do if we wanted to, change things a little bit more is we could do an additional statement over here because we want to see and we want to be able to compare them from each other. So how about instead of just having the sum, we already now have the sum, which is this total sales. I want the average of the total of the product sold. So the average should give me how many items they sell divided by how many calls. So instead of going that long way, I'm just going to use the average function. So I'm going to do average call dot product sold. Actually, I should have had this over here as well, but it doesn't matter. Product sold as this is success percent. So again, remember, the product sold is just ones and zeros. So if I have 50 calls and I made 25 and 25 of them have a 1, this average is going to take those 25 and divide them by 50. So it will give me the average of how successful I am when actually doing my calls. And finally, I'm going to change something, and my order by is going to be by success percent. And it's going to be descending so I can see who my best agents are. So when I run this, we get Gloria. For example, this is my best agent apparently. with 926 total calls, 209 total sales, and 0.2257, so about 22.5% success rate. So this divided by this gives me about a 22%. And this is going to help me figure out who my best agents are. So difference between group by. So group by is going to tell me how to group this information. So as you can see, remember, if let me actually, I actually have to do it. Remember when we did the group by before, and sorry, not the group by, the count and the sum, and we got the numbers for the whole table. With the group by, it's going to divide, so it's going to count all the calls, but in this case, it's going to count all the calls that belong to Gloria Singh. And it's going to count how many sales, or sum them, that belong to Gloria Singh. So the average, we're using the average function. So average call product sold. So we're using the product sold table, this one over here. Oops, product sold over here, which is a Boolean. So remember, that one has ones and zeros. So it's just going to sum up all the ones and divide them by the count. So with the query that you send me, you have a comma on the last part of the select statement. Remember, this last one doesn't have a comma. If you put a comma there, it's going to give you an error. What do you mean by average sold? To be a percentage? Yes, but again, see, these are the extra things I don't actually want to do right now. So yes, we can. So we just have to add something like 100 times average, and it's going to give you the percentage, 22.5. And then we can also use a round function, but we'll get to it in a bit. Yeah, you can multiply by 100, and it's going to give you the number out of 100. All right. So let's take a break, because I know this is a lot. Let's take a break. When we come back, I'll do an additional example for figuring out how the joins actually work, the left join, the right join, that might help you figure it out and understand it better. Yes, it is a lot. And how to do aggregate functions, because I actually want you to go through this and make sure that then you can go through the video again over and over again until you actually can practice this and do it by yourself. By the way, we still have a second session, which is on Thursday, about this same subject. So if we need to take more time, we will. So don't stress out about it. All right. So I know you're ready for a break. So let's take a 10-minute break. Go stretch your legs, grab a snack, grab a drink, and we'll be back with an interesting explanation of joins. And if you have questions, again, feel free to just post them on the chat. All right, I think we're back. But before we go back into the subject, because there's still quite a bit, because it's very important to understand the different joins, I actually have a little exercise that we're going to play around with. So let's imagine that we have two tables. We have table 1, which is a table of owners. We have 4 owners. They have their own ID, 1 to 4. There's John, Jill, Paula, and Jake. And they have a pet ID, which is the pet that they own. We also have 4 pets, 1 to 4. And their names are Shark, Tiger, Wolf, and Pumpkin. We know their favorite snacks and what pet type they are. All right. So here's a question. Let's start with an inner join. So if I join both of these tables together using an inner join, meaning that I want the information that is part of both tables. And remember, in this case, I'm going to use pet ID to connect them. So pet ID here has to be equal to pet ID over here. So the question is, what information do I get back? So first of all, if I do an inner join, what information do I get back from this table? So from this table, look, we have 3, 2, 1, 2. and we have these three. This one's 5, so this one does not connect to this one. So yeah, we're going to get these 3 owners, and we're going to get their respective pets. So pet 1 goes to owner with pet 1, pet 2 goes to owner with pet 2, and pet 3 goes to owner with pet ID 3. All right? Is that clear? So do we understand how these 2 tables get joined together with a regular join? So as you can see, these 3, because this is an inner join, the stuff that belongs to both tables. Great. Let me actually move all of this down. Now let's think about a left join. What happens if I do a left join in this case? So what information do I get from this table over here? So do I get all of the owners, or do I only get some of the owners? So if I'm doing a left join, I get everything from the left table, and that's very important. So I get everything from the left table. And then I connect to the stuff that's on the right table that connects to it. So I get the first pet to the first owner, I get this pet number 2 to the owner of pet number 2, and I get pet number 3 to the owner of pet number 3. But here I get nothing. As you can see, this stays empty. Why? Because pet with ID number 5 is not on my second table. And that's what becomes important. So this is a left join. As you can see, it's a little bit different from a full join. Sorry, from an inner join. So the inner join gives me the stuff that's in both. In this one, I get everything from the left table. All right, let's do one more. What about a right join? What happens if I do a right join in this case? What do I get? So this one's interesting. So, and here's where we need to think about the logic of it. So if I'm doing, thank you, Gabriel. Yes. So if I'm doing a right join, the first thing that's going to happen is I'm going to get everything from the right table. So the thing that I do is this, and I want you to see why this is a little bit different. So I'm getting all of this, all of the information from the right table. And then on the left table, in this case, I only get the stuff related to the pets that I got from the right table. So this one goes over here, and this one goes over here. All right. So as you can see, a left join gets everything from here, and a right join gets everything from here. All right. Let me open one more. And now is the interesting one. What happens if I do a full join? What's the difference? So I already know what happens on one or the other. So yeah, I do get everything, but remember, so if you, I do get everything, but I don't get it like this. Oops. It's not like this. This would be wrong. Okay. I actually get everything. I get everything from my right table, and then things start getting connected. So this one goes over here. This one goes over here. Oops, I missed number 3. This one goes over here. And where does this one go? Where does this pet number 4 go that doesn't have an owner? It goes here. Oops, correct. So this one would go over here. So there would be a gap in the middle because there's no pet information for this owner, and there's no owner information for this pet. But this is the table that I get in the end. All right, so I do get another table. Yeah, probably you'll get null values. So the important thing is that it's empty. Okay, don't worry about its null values, but yeah, we can insert null if you want to. So yeah, this could be just null values because there's nothing there. Same with the other ones. Oops. So same with the right. So these would be null values. Let me just grab a null over here. So this would be null values. And on this one, this would be null values. All right. Yeah, I will actually share this at the end of the session so that you have it. More than screenshots, I will actually share this document with you by the end of the session so that you have it and you can go through it, because this is going to help you understand exactly how tables are get joined together. All right. So going back to what's happening, we're doing some aggregate functions. So one of the questions, wait, what's that question? We only have, but we will have only one column for pet ID. What do you mean? No, so that's an interesting one. Do we get only one table for pet ID, or do we get both? So here's that's an interesting question. Select all from agent join call. So here's an interesting one. Look, you actually get both. You get the agent ID from the agent table. You get the agent ID from the call table. Oops, actually, no, this is, sorry. Bad me. I forgot the on statement on agent dot agent ID equals call dot agent ID. I just did a cross join. I don't want to get you. So again, you get agent ID over here and you get agent ID over here. So it does get copied. Okay, that's important. Same here. You do get pet ID and pet ID because they belong to different tables. They don't get joined magically. All right, you still get every single row, unless you ask not to. If you only get one of the agent tables, but that you would have to pick on your select statement. All right. So before the break, we were here. Let me actually just, sorry if this looks not so orderly. So we had the success percentage. I hate how it looks like that. So from at least like that. All right. And again, if you want to look as a percentage, just multiply it by 100 and you'll get it more like as a percentage. You cannot, you can add the percent sign, but I don't want to get, it's more complicated than we should. All right. So we can see with this information that our top performer seems to be Gloria Singh. All right. That's simple. It seems like this is an useful metric. And most of the agents actually fall within about 1%, you know, at least most of them, except for Angel, who's down to about 17%. So, you know, 17, then it jumps up to 20, and then it goes up to about 22.5. So this is what I want you to do to start working a little bit more on it. Let's actually modify this, because to see if this is actually fair, we need to remove some things. So this is a financial services company. So only customers over 18 can actually purchase something. And we also don't want to punish our agents because nobody answered the call. So this is what I want you to do. I want you to filter out these results. So it's exactly the same, this same query. I'll share it with you in just a second. All I want you to do is to modify it so that it only takes into account customers that are over 18 and calls that were answered. So just in case, customer age is in the customer table, and whether the call was picked up or not is over here. It's a Boolean, so it's 1 for yes, 0 for no. So on this one, let's actually reset. I'll give you 4 minutes for this one. So Jeffrey, that's why do I write the queries like this? So it's a readability thing. So there are some better practices. I mean, you can write the statement anywhere you want. You don't even need to do caps. You can actually do everything. But this, for me, makes it more readable. So see, I know because all of these is sort of on the same place. Plus, I do Python a lot. And you'll see with Python why this is important. So I know that all of these is part of my select statement. I know that all of these is part of my from statement. So it just makes it a lot easier to read. So that's a great question, Sidesh. Will the query order affect your result? Well, it depends. The question here is, we're okay with just doing joins. We're not necessarily doing left or right or full outer joins. So you're good enough with, you don't have to worry about the order if you're doing full, just inner joins. So inner joins, the order only affects how everything's shown. But if you select the specific things that you want on your select statement, then it's not a problem. It shouldn't affect your result. So good job so far, the ones who have answered, most of them. So again, we want to change this to filter out any customer that's under 18 and any calls that were not picked up. All right. So what things do we have to do to this query that we already did to get rid of the other stuff? In other words, to remove mostly people who are under 18 and the calls that were not picked up. So the first thing that we definitely need to do is we also need to join our customer table. So exactly. So double join is just, so here's the important thing. Joins are done consecutively. So once this join is done, this becomes one table. Then you do another join, you're just joining that table to this new big table. So you can actually mix inner joins, left joins, etc. But in this case, we're just going to do another inner join. So we're going to join, this case is customer, and we're going to join it on, which one was it? Customer ID. So on, it's call dot, I think it's like this, customer ID equals customer dot customer ID. And that should solve that part. Now, what's next? What else do I need to do? Where does my filter go? Do I put it after the group by, after the order by? Where's my where statement? All right, yes. So after my from statement or my join statements, here comes the where. So the first part of the where, and yes, definitely before the group by, very important, I actually have to do call dot picked up, I think is the name of it. Yep, picked up. This should be equal to 1. And because that's not the only one condition, we have 2 conditions. The customer age, customer.age, has to be bigger than or equal to 18. All right, and we're going to group by agent name, and we're still going to do success percentage descending. So again, we just modify this a little bit. Now, here's a question. Do you expect the order of performance to stay the same, or do you think it's going to change? So as you can see right now, Gloria is my top performer. Let's see if she's still my top performer after I run this. And it turns out she's not. She actually fell to number 2. And Todd now becomes my top performer, because once we remove the calls that were not picked up and we remove the people under 18, it turns out that Todd has a 33.5% almost. So that's interesting. So it's important that we think about, when we're measuring performance, we need to think about how does the data that we have actually affect that performance. So imagine if you're calling, I mean, if we kept the other one, we would be punishing anybody who spends all day trying to call people but nobody picks up, or that the people who pick up are under 18, which happens. All right, so this one's just fast. So let's do this one together, this exercise 5. So let's actually just do a query where we find the average, minimum, and maximum call duration for each of our agents. And we're going to make sure that we're only going to take into account calls that have greater than 0, meaning that they lasted more than 0 seconds. Oh, that's a great question, by the way. Let's actually check that one out. So if I do this, this stays the same. So why do you think if I remove the call.pickup equals 1, that one gives me this result? And if I remove the equals to 1, I get the same result. Any idea why? This is going to become even more common when we move into Python. So yeah, it's a Boolean. So because it's a Boolean, picked up is going to say 1 means yes, 0 means no. So true or false. So it's sort of a true statement. So whether you put the equals to 1 or not, it's still going to only pick the calls that say 1. That's it. And it's going to become even more common when we actually move into Python. So again, let's do this other exercise. So we want to find the average, minimum, and maximum call duration. So here we're going to use some other aggregate functions. So I'm going to select, the first thing that I'm going to select is the name of the agent, because we need the name, agent.name. Is it, yeah, it's name with a big N. And yes, just in case, let's call it agent name. Oops, forgot the comma. Great. Then we want the minimum call duration. So we're going to min call duration. It's call, oops. It's call dot duration. Give me just a second. I don't know. Sorry, yeah, call dot just duration. It's duration, big D. Duration. And as min duration, then we're going to do max call dot duration as max duration. And do we need something else? Oh, an average call duration. So average call dot duration as average duration. Okay, so from where do we want to get the first information? I'm actually going to take call just because it doesn't really matter. I can actually do it the other way around as well. It's going to work. But let's do call because I think that's the most important in this case. Then I'm going to join agent and we're going to join on. call.agent ID equals agent dot agent ID. And we just need to make sure that there's a where statement where call.duration is bigger than 0. So in other words, anything that is not equal to 0. And we want to group by, very important. By the way, any idea what happens if I don't use a group by statement and I try to run this? Thank you, Dustin. That's the one. Yeah, it's not messy. It's just that the aggregates won't work. So it's just gonna do something really, really messy and ridiculous, which it makes no sense. So this is the minimum duration, the maximum duration, the average duration, and the one agent name, which absolutely I don't need. So I definitely need to group by. And let's do a little shortcut. I'm gonna group by one, which is the first thing that I put in my select statement. Just a little bit of a shortcut. And here I get all of the information, the minimum duration, the max duration, and the average duration. And if I wanted to know the agent that takes the longest on average, so order by, well, average duration is 4. That should be descending. Very important. If not, it's going to give me ascending on by default. All right, so Gloria is the one that takes the longer. And by the way, she's also a very good performer. So apparently it might be that the length of the average call actually helps a lot. So this is just a shortcut. So group by one is the same as group by agent.agent agent.name, sorry. Why? Because this is the first argument on my select statement. So that's why I'm doing a 1. And 4 is my fourth argument on the select statement. So this is just like the columns that I pick up here. Remember, these are the columns of my view. So I can actually just do that as a little bit of a shortcut. All right. Ooh. Okay, so let's talk a little bit about handling null values. So I'm going to go through a couple of these exercises with you just because of the time constraint. And I'll let you do the last couple of ones. We'll probably leave a couple of them for Thursday. All right. So we actually looked at the ERD at the very beginning. We have the agent ID, customer ID for agent and customer tables. That's how we connect everything. But we have a weird agent that doesn't appear. So let's actually figure something out and see if we have any agents that are also customers, because that could happen. So how can we find, let's actually walk through this one together. How can we find, using our tables, if we have a customer that is also an agent? Any ideas? We could try and match names, yes. So how do we match names? So let's select, in this case, if we want to match names, we can select everything. From which table should we want to start? Let's say we start with our customer table, just because it's bigger. Customer. And we want to join, join our agent table. And we want to join it on. What do I join it on to join these two tables together? If I want to match names. Customer.name equals agent.name. So what do you expect to see if I run this? Well, the problem is, here's an interesting question. If I want to check on IDs, does the customer table have the agent ID, or does the agent table have the customer ID? So that's the problem. We don't have, these two tables are not connected. They're connected through the call table, but they're not connected between each other. Exactly. So call table is the one that has both. So if I want to avoid that, I just want to check very quickly if we have any clients, any customers and agents that have the same name. So that would give me some idea. And when I run this, I get nothing. Do you actually expect this? Or, I mean, did you expect to find a customer that's also an agent? Exactly, not really. I didn't expect anything. This is not common, especially if we're talking about a financial institution. So let's actually do a sanity check. And in this case, to do a sanity check, we're actually, just to make sure, we just want to make sure, because remember we had some weird information. So instead of just doing a regular join, this is an inner join, let's actually do a full join. All right. So if we do a full join, we're going to literally connect both tables. And I just want them to connect on customer name equals agent name. Now, here's a question. How many rows do you expect nothing, or do you expect some rows if I do a full join? Remember this. Remember our full join over here. Well, no, 9,940 rows is my call. 10 extra rows. So here's the thing. If I do a full inner join, I should actually get all of the rows from my agent table and all of the rows from my customer table. Remember, it's a full join. It's joining everything together. So when I run this, this is what I get. So as you can see, remember I started with the customer table, so I get all of my customers first. And then on this side, I get agent ID and name null, all of these null values. And then my agents should be all the way at the end. There you go. And here's my agents, where I have their information, but nothing else. So they have all of my agent information, but there's no customer information. So in other words, I'm actually getting a little bit over 1,000 rows, because it seems I have 1,000 customers and 11 agents. So I get 1,011 rows, which is what we expect. And there's going to be a lot of nulls, because remember, when we were doing or full joins, we get null values. We get null values where things don't match up. And in this case, nothing is matching up. Yeah, where customer, well, that's an interesting one. So the thing is that, by the way, if I do a where statement and I put this, I get the same result as if I do an inner join. So this is a little bit redundant. That's why we wanted to do a full join, just to check and make sure that I am getting all the information. And I am. Here I'm getting 1,011 rows, 1,000 customers and 11 agents, but nothing is matching, which is perfect. We actually expected that to happen. So again, remember, the join is going to try and match each entry with the first column, in this case, customer name, with the ones from the second column, the agent name. It's going to try to match them. And if it can match them, it's just going to individualize those columns. So that's one of the big reasons why most of the time, if not all of the time, unless we're doing something very particular, when we're joining tables, we join them on IDs, because the IDs are supposed to be unique identifiers. And that's the way we can make sure that we handle and we reduce the amount of null values that we find. All right, so let's actually do a little bit of an example of how this works. And we're going to join customer and call tables with using the foreign key customer ID. Okay, and in this case, yeah, customer, let's actually do over here. Let me just organize it in a way that it's much more readable. What's happening here? There you go. So this is something particular that I'm going to do. We're going to get a little bit into the whole inner query idea, or subquery in this case. Oh, Hassan, if an agent was also a customer, you would, when you join those two tables on names or on, you might actually find them. But the thing is that if you look for them on the IDs, their agent ID and their customer ID are going to be different. So think about somebody. So for example, how many of you are clients of Amazon and work at Amazon at the same time? Is your ID the same? Is your client ID the same as your job ID? So the only way to find out would be to check your name. And maybe that'll mix, maybe it can't. That's the thing, Jeffrey. It can't be. You can't. So the IDs are completely different. But once in a while, so if somebody wanted to check how many of their employees are also customers, they would have to check something different. They would have to check something like their names. All right. So look at what I'm going to be doing here. So here I'm doing a subquery. So in other words, instead of using a from one particular table, I'm actually going to do a query inside. So just to give you an idea of how it works, we'll join call on where, let me put this back a little bit. Yep, there you go. All right, so let me remove this. Okay, so what I'm doing, look at this. So this is a query. So select all from customer. I'm doing a full join on call on customer ID equals call.customer ID. So here I'm trying to figure out the customer ID from customer and the call table where name is null. I'm trying to find any clients in this case that don't have a name. So I'm actually going to just run this query first. Okay, just for you to show what it pops up. So this is what's popping up. See, we have 15 clients that don't have a name. Interestingly, all right. Call ID, customer ID. So we have customer ID over here, but not over here. So in other words, we have the customer ID on this side, but there's nothing here. There's no customer ID number 1000, although there are calls, which is interesting. So this is the inner query. This one over here is the inner query. I'm just selecting that inner query. So what I'm doing is I'm actually, when I do select from, it's going to look exactly the same, but I'm actually converting this view into my select statement or into the table that I'm trying to select. And I'm just calling it customer outer call. So when I run this, again, this is what I'm going to get. It's going to be the same 15. But I want you to show is that I can actually put a select statement inside my from, and that becomes the table that I'm querying. So if you want to view the inner query, you just run the inner query by selecting it. Or you just run it first, and then you put it into an inner query. So this is interesting. So we have some calls that, they do have a customer ID, but apparently we don't have that customer ID on our table, on our customer table. That's why all of these are popping up null. So that's interesting. So could we do the same for our agent table? And the answer is yes. Let's actually do something similar on our agent table and see what happens. See if we have something weird and that is not working there. So again, I'm going to do from, and inside my from statement, I'm going to do a subquery that is going to call the agent table. It's going to do a full join on the call table where name is null. So I'm trying to check to see whether we have any null values on the call table for my agents. I'm going to run this, and I do. Remember our agent ID -1 that we saw at the very beginning? There is a call registered, but there's no agent. There's a customer, but there's no agent. Probably nobody picked up either. Or at least we don't have the information on that agent. All right. So in this case, we actually expected this null value, or at least I did, because we already saw that there was one call with no agent. We also now know that there are no calls. I have 15 calls with no customer. So let's see if we can actually try to merge both of these tables. Remember, we want to see anything that doesn't have either an agent or a customer. So we can now, because of what we did, we can now actually join them together. And the way we're going to do it, let's actually this is going to look a little bit intimidating at the beginning, but let's organize it. So what I'm going to do is I'm going to do a select all from this table, which is my, so remember, my from statement is going to be my selection on a full join for my customers. All right, for my customer call. So in other words, just to show you, this is going to show me all of the calls that have no customer. Okay. And then I'm going to full join that one with another table. In this case, oops, I'm going to full join it with another table, which is the other table that we did, which is going to work for the agent. So this is the table that has any calls that don't have a name or for the agent. Okay, and this one's going to move a little bit backwards just in case, where customer outer name equals agent outer name. All right. So what I'm doing here, again, this is one table. This is my subquery. I'm doing a query for this table over here. Okay, and so this is all of the calls that don't have a customer. And these over here, this other subquery is all the calls that don't have an agent. Okay, so there's one here and there's 15 over here. So all I'm doing with them right now is I'm actually joining them together. I'm doing a full join between them. So what's going to happen when I join a table that has one row with a table that has 15 rows if I do a full join? Exactly. Subqueries is a query within a query. So just think about it like this. Inside here, I'm creating a table that has 15 rows, as you can see, from 1 to 15, of calls that do not have clients. And I'm joining it with another table that has one row for all the calls that don't have an agent. So if I'm joining them together, one that has 15 rows and the other one has one row, how many rows should I get? Yes, we're getting 16 rows. Oops, I actually have to run it like this. We get 16 rows in total. So I'm going to get all of the rows from my first table that have no client. And at the end, I'm going to get all of those rows that not only don't have a client, but don't have an agent either. So no customer, no agent. So in my whole database or relational database, I have 16 calls that went nowhere. They did nothing. Okay. So that's what you can do with subqueries. We're going to go through more of subqueries on Thursday, because there's a lot of places where you can put them. You can put them in a from statement. You can actually put them in a select statement. You can put them in a where statement. And that makes it very, very interesting to use. So just think about it like this. A subquery is a query that we put inside another query so that we create a view, a table that we want, and then we query that table one way or another. And there's a ton of ways to use it. I know it sounds a little bit confusing at the beginning, but once we use it over and over again, it's going to become a lot clearer. All right. So, so what happens if I change this? So here I did a full outer join. What happens if instead of a full outer join for this table, I do an inner join? What do you think is going to change? Oh, that's not the one. Sorry. This one over here. So that's an interesting one. If instead of a full outer join, I just do an inner join. So I get blue screen, empty, nothing. Kishan, CTEs, we're going to cover them later. If I add another subject today, we're going to have issues, I think. Yes, it's a lot of info today. So just go through the video afterwards. I will talk a bit right at the end of the lesson. So here, as you can see, if instead of a full join, I just do a regular inner join, I get nothing because there's nothing to join. Nothing belongs, there's nothing that is in both tables at the same time. So that is interesting. All right. I'm thinking to see. Sophia, if you can share your code, that'll help a lot. So let's actually do one more little thing today, just because this is probably going to help us understand our subqueries a lot better, is using our in statement. And it's using so in statement is, we can use it in the where. That's going to help us just select or filter things when we have more than one thing that we want to look for, instead of having to do or. Remember that we could do or. Well, the in statement is going to change that. So here's an interesting idea. So let's say that I wanted to select everything from the customer table, and I just wanted to check certain kinds of ages. So, people who are 18 and 20, let's actually just do those. So I could do age equals 18 or age equals 20. So that's one way to do it, right? So if I do this, I'm going to get all of my customers that are either 18 or 20. And I can actually go all the way over here. So we can see they're 18, and then there's 20 or 18. That's it. Now, if I also wanted people who are 25, I could go or 25, or age equals 25. If I also wanted people who are 30, or age equals 30. So I can keep going with the or statements, but it can get confusing. It can get complicated. There's too much. So that's why, if we have too many things that we want to look for, instead of doing an or, we can just do an in statement. So we go age in, and then we put in brackets all of the values that we're looking for. In this case, 18, 20, 25, 30, and 35. This is the same thing as doing age equal 18, or age equal 20, or age equal 25, or age equal 30, or age equal 35. So we're replacing all those or statements with just one in statement. And that's what we get. We get everybody who's 18, 20, 25, 30, or 35, whatever values we put in here. Now, we can also use the in statement with a subquery. Remember, we can use subqueries in where statements. So I can select everything from my call where customer ID in, and in here I start my select statement, select customer ID from customer. So what I'm doing here is I'm actually creating this. Oops, I have to put a bracket in it. If not, I'm going to get an error. So here, I'm actually just selecting a list of IDs. See, these are all my customer IDs. Every single one of them. Okay. I just get all my customer IDs. And I'm saying that I want everything in the call table where the customer ID is in the customer ID table. So again, all I'm doing is I'm taking this list and transforming it. So this list that I created with a select statement, and transforming it into the list that I'm passing into my in statement. So when I run this, I actually get all of the calls from these customers, which I know it's all of them. But we could do some where statements and some extra things. But the cool thing is that here is another example of where I can use my subqueries, my queries inside my queries. So, okay, let's actually move. Now, I'm actually going to stop and ask you if you have any questions. There's a couple more things that I want to cover, but we can actually cover it on Thursday. So I'm just going to open up the field for the next few minutes for questions in case I need to repeat anything that we went through. All of them. So here's an inter where is less than or equal to 10. So here's an interesting thing, just in case you. So let's say that I actually wanted just customers that have IDs less than 10. So this is my list. See, this is my view. I do it with a select statement. And I can actually pass that into the in, so I only get those colors. So again, only customers ID that are 10, 0, or 1. So yeah, again, definitely more practice. It's very important to practice. It takes a while to grasp it. There's a lot of stuff that happens. SQL is really cool. And by the way, remember this idea of how to build tables, we did it because we want to remove redundancy. We want to do a lot of cool things with data. And that's why SQL is so cool. How can we join more than 2 tables? Well, select all. So this is joining more than 2 tables from agent. And I'm just going to join a call. And I'm going to join it on call dot agent ID equals agent dot agent ID. So that's my first join. Okay. So once I do this, this is already creating a table that joins agent and call. Now I want to join customer. Join customer. So I just do another join. And in this case, on customer dot customer ID equals call dot customer ID. So the important thing is to know where to connect them. So what I'm doing here is I'm taking the agent table. Let me actually open this up. So I'm taking the agent table, connecting it, this agent ID with this agent ID, and then that creates a new table that is these 2 tables together. And now, next, I'm actually joining this customer table on customer table ID equals this customer ID. And that's how you join more than 2 tables together. And you can just keep going. I mean, there's no limit. You can just keep doing joins, 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 join. And as you can see, when I call this, I actually get all of the information. This should be 9,924 rows of information. Now, these are inner joins. So we are losing it's let's see, 9,924 and it's 9,940. So the 16 columns that have null values, those are not going to show up. So the tips for understanding it is going through it again and practicing and just trying to get the information that you want. But practice. Sometimes even after years of doing this, you can actually look at a very complex data schema, relational database schema, and you go like, oh boy, how am I going to do this? But then you just take it one piece at a time. We're actually, again, we're going to cover this. We're going to cover CTEs, which are going to help you do one table and then querying that table. So there's a lot of tools that SQL gives us. Can you have a subquery with another subquery? Yes. You can just keep going on with the subqueries, but generally that makes it really complicated some. So what we do in that case is we use CTEs, which we're going to cover next lesson or next week. I'm not sure. Shouldn't it give all columns from call that matches? Depends. Not sure I understand the question. Shouldn't it give all columns from call that matches customer ID in customer table? So it depends on how you do your query, but yes. So yeah, primary key is this, just in case. So this is a primary key, agent ID, for the agent table. Call ID is the primary key for the call table. Customer ID, primary key for the customer table. This is a foreign key. Foreign key just means that this is the key, the primary key of another table. Oops, wrong table. Of another table. This is also a foreign key, which again, it just means that this is a primary key in another table. And generally, every single table should have their own primary key. So MySQL every SQL is the same SQL. There might be slight differences on like 1% of the stuff that you do on them, but they're very, very slight. I mean, there are differences, but they're very, very small. And everything that we're covering here should apply to practically every SQL flavor or difference. How much time do we have? Actually, all right. So, Clara, I would love to re-explain that. My suggestion is go through the video because I know there's quite a few announcements to get through today. So let's move on to announcements. Please feel free to just keep adding questions. I will share with you the table that we did today. And remember, it just takes practice. You just need to practice, and it's going to become clearer and clearer the more that you practice. All right. So